Last lesson was about independent events, where one event had no effect on the probability of the other. Now we are talking dependent events, where the occurrence of one event does affect the occurrence of the other. The formula is the same, it's just worded slightly differently. So if A and B are dependent events, then the probability of A and B occurring is equal to the probability of A times by the probability of B, given that A has occurred. So it's the same formula, but you're acknowledging that A must have occurred because A and B have effects on each other. So get that formula down, please. And we'll do 2 examples. Very short lesson. All you're answering is 1, 3, 5, 7. Please notice it's Cullen with a C. Okay. See, that's an Ignite level thing to do. So in that rectangle, formula for your cheat sheet, once again, one-sided A4 handwritten. A fruit bowl contains 3 apples and 5 oranges. Cullen selects a piece of fruit at random and eats it. His sister Michelle then selects a piece of fruit for herself. Find the probability that both pieces of fruit are apples. Find the probability that Cullen selects an orange and Michelle selects an apple. Thinking. You don't need to write this, but this is the first question that we're doing. Why are those events dependent on each other? Yes?
Because the amount of such fruit will change up to
Yes. The fruit is eaten and it's not returned, so the chances change. The total amount of stuff changes. So probability of A and B is equal to PA times by PB given A has occurred. What is the first thing that's occurring? So the question states that Cullen is selecting a piece of fruit first. So a probability of, what was it, apple? Apple and apple. What's the probability of Cullen getting an apple? 3 out of 8. So you corrected it because it's not out of the number of oranges, it's out of the total number of fruit. So 3 over 8 multiplied by, given that an apple has been taken away, what would the chance for Michelle be of getting an apple as well? Yes?
2 over 8 or 1 over 4?
Is it 8 anymore?
Oh, sorry, 2 over 7.
Good. I like that we're all working together to work. So yes, the number of apples is reduced, but that reduction also affects the total. So these numbers aren't going to be as nice anymore. If you've been doing the timeline exercises, what you'll notice is the fractions sort of stay the same. Here, these fractions are changing, and your answer is going to be completely different if you don't take away from the total number of apples and the total number of fruit in general. 3 times by 2 is 6. 8 times by 7, 56. Does 6 over 56 cancel down? Are they both even numbers? 3 over 25, 26, 28. Does 3 go into 28? No, it's 27 it goes into. So there, that would be your first. Find the probability that Cullen selects an orange and Michelle selects an apple. So, P, orange, and apple. What's the probability? It's going to be over 8, but what's his chance of getting an orange? Sorry, say it loud. Say it just 5 out of 8. Now keeping in mind it's dependent. Does the orange being eaten by Cullen or selected by Cullen, does that affect the number of apples? No? So it's Michelle selects an apple, so it's going to be 3, unlike before where it changed to 2. But is the bottom number going to change?
Yeah.
There's 1 less fruit, so 7. 5 times 3, 15. Over 8 times 7, 56. What are the numbers that go into 15? 3 and 5 is 56 divisible by 3 or 5? Let's check. 3.
It's not 3 or 5, sir.
No, neither. So you just leave it at that. I'll give you a few moments. Can you get that example, please? We'll do one more. You can talk, just don't say names.
No, I was kind of having a time like but at the same time, I have to get the perfect name.
1 minute.
Which is No. I mean, I probably should just look at the same check off. But you know. And then like it's not gonna fuck right. I had
All right, second example. Shush now. A container holds 3 banana ice blocks, 4 chocolate ice blocks, 2 raspberry. George randomly selects an ice block from the container and eats it. Brother Oliver then randomly selects an ice block from the container. Draw a tree diagram. These are, for some reason, these are my favorite. I like them for some reason. George would be the first set of branches. Oliver would be the second. Looking at that situation, how many branches should there be for George? 3. What should those branches represent? Banana, chocolate, raspberry. George randomly selects an ice block from the container, eats it. Brother Oliver then randomly selects. How many branches should come off of the top one? 3 still. 1, 2, 3. 1, 2, 3. 1, 2, 3. Same choices, but the chances are all going to be different as far as I can tell. So George's selection. What is the total number of ice blocks that he could choose from? Work that out first. 3 and 4. Is it 9? Let's make it 9. I'll do it in red. Something over 9, over 9, over 9. The numbers on top should add up to 9 if we did that properly. What's his chance of getting banana? 3. Next. 4. 2. 3 plus 4 plus 2. 9. But now, you have to dig into this and actually look at the branches. What's the number going to be?
all of them are going to be over 8.
They're all going to be over 8. So we can... there's not much space here, so my bad. But you're going to have to deal with that too. Over 8. I'm just going to do them vertically in order. Over 8. Over 8. Over 8. If George selected a banana, how many bananas would there be to choose? 2 over 8. 4, 2, because the banana wasn't, the 4 is not banana. Next. 2, that remains the same. Now, what's being chosen first? Chocolate. So the top one's going to be 3, 8. This one's going to be 3, 8. And this one will be 2, 8. Then the bottom one, banana is unaffected, so it'll be 3, 8. Chocolate unaffected, 4, 8, but this one will be 1, 8. That's A. I'll leave this up. B. Find the probability the brothers select the same type of ice block. How many different complete branch pathways is the same? Yes, I like that. Some people have jumped out to me and said 1, but it's not. They can do
B, B, C, C, R, R.
B, B, C, C, R, R. So you've got 3 probabilities to add. So the probabilities you're going to be adding, probability same is going to be 3 over 9 times by 2 over 8 plus, what would the next one be? Not just you, there's other freaking people in this class. That second branch that I highlighted. What's the chance of getting a chocolate, the first choice? 4 over 9 times by, what's the chance of getting the chocolate second? 2, no, I think it's 3 over 8. That's my writing, but I didn't have enough space. Plus, then the last one, chance of going down, 2 over 9 times by? 1 over 8. Okay, P, same. 3 times 2, 6 over, what's 9 times 8? 72. Plus 4 times 3, 12 over 72. Plus 2 times 1, 2 over 72. Do these all have the same denominator?
Yep.
So can I add them together?
That's 20.
12, 18, 20 over 72. Both even numbers, so 10 over 35, 36. Still even, 5 over 18. I think that's the end of it. You've got a 5 over 18 chance that the brothers select the same type of ice block regardless of the type.